Hello everyone, my name is Viraj, and today we'll be looking at the 12th problem from the CP-31 sheet by TLE Eliminators under the 800 rated questions. Let's go. So I'll be moving on to my TLE 31 sheet over here. I have 800 rated parameter ticked off, and I'll be going on to my 12th problem, sequence game. Alright, let's open this. So Tima and Vika are playing the following game. First, Vika comes up with a sequence of positive integers a of length m and writes it down on a piece of paper. Then she takes a new piece of paper and writes down a sequence b according to the following rule. First, she will write down a1. Then she will write down only those ai from 2 less than equal to I less than equal to m such that ai is greater than equal to ai minus 1. Let the length of this sequence is n, something like that. So they have given you an example over here. Let's say the sequence looks like this, then you will get the sequence as this. Now what is asked, the thing that is written is, she is going to give this piece of paper with this new sequence b to Tima. He in return is going to guess the sequence a. So you will have to guess the sequence a for Tima, that is help him and output such a sequence. Okay, I want to know at least one such sequence A that could have been initially chosen by Vika. Alright, so let's try to generalize this problem and understand. So basically there are two players who are playing this game. We don't need to go into who is playing what sort of a game and everything. Just what's the base point of the whole question, we need to understand that part. Okay, what they are saying is, they are saying a variable m, and they're saying there is initially an m-sized sequence A. So I'll call these numbers A1, you have A2, you have A3, so on, so on, so on. You have till the number m. Now from this A array or m-sized array A, you create a new array which is of n size, which is called array B. Alright, array B. I think I did some mistake over here. Yeah, let's go back. Array B. So this array B has the numbers in a specific condition that you have to follow. What they are saying is, you create this array B from the array A. But how do you do it? You basically say that I pick up A1. So A1 of course is present in this array B. And then I start my pointer, let's say from here. That is from second position in 1 base index. And then I ask myself, is my current number greater than, let's say this A number is AI. AI is greater than A of I minus 1. If I ask that is my current number the ith position that I'm standing at, if it's greater than equal to that current number, I will write this number. So let's just say that A2 in this case was greater than equal to the previous number, that's A1. So I will definitely write A2. I will write down A2 over here and I'll say, okay, yeah, A2 is a number that I can write. I'll write A2. Let's say I went to A3 next time and A3 was not greater than equal to A2. So I will not write down A3. I'll skip A3. Let's say I'll move on. I go to the, let's say I have some number over here, A4. Then I have A5, dot, dot, dot. So let's say I go to A4. A4 is greater than equal to the previous number, that's A3. So I'll write down A4. Then let's say A5 was not. So, okay, fine. Let's skip A5. Then maybe let's say A6 was, then I'll write A6. Then maybe let's say A7 was greater than equal to the previous number A6. Let's say I'll write A7. Then maybe so on, so on, so on. Maybe let's say the last number AM was greater than equal to the previous number. So I'll write down AM. This is how you can see the simulation. You can understand the simulation of how I have created the array. I have created an array B. Of course, the size of this array B is now going to be something else. That is why they have taken this variable n. So again, I'll repeat. Start off with an m-sized array A. From that, create a new n-sized array B. And when you create this, follow some rules. First rule is just copy down the first number. So just copied down the first number A1. And then after this, for every number, you ask yourself, is this number greater than equal to the previous number? That is this condition. Do you think that AI is greater than equal to the previous number or AI minus 1? If you find the answer to this question as yes, you say, okay, this number is fit to be jotted down in the array B, or else you skip this number. So assumed that, let's say A2, if I jot down A2 in the sequence B, that means A2 in the original sequence A is greater than equal to its previous number. Let's say I did not jot down the A3 number, that means A3 in its original sequence was not greater than equal to the previous number, that's A2. Let's say I jotted down A4, it must be. Let's say A6, it must be. Let's say A7, it must be. Let's say so on until AM, it must be. So any number that gets jotted down or goes to the array B should be greater than equal to the previous number in its original array, that was the array A, or the original sequence that we have called array A. Okay, this is the whole problem. So now if we understand the case again, you will get to understand what are they saying. So let's say you have written 432 633. So I'll write this over here, 432 633. So this is array A. Size of this is currently 6. Let's create a array B. Open it. Jot down the first number as it is. So I jotted down 4. Now I start off my asking from here. Is this number greater than equal to the previous number? No, 3 is not greater than equal to the previous number. That's 4. So do I copy down 3? No, I don't copy down 3. I'll go to 2. Is 2 greater than equal to the previous number? That's 3. No, it's not. Fine, don't copy down 2. Let's go to 6. Is 6 greater than equal to the previous number? Previous number is 2. Of course, 6 is greater than equal to 2. So do you copy this number? Yes, you do copy this number and it is fit to be jotted down in the array B. Next, you go to 3. Is 3 greater than equal to the previous number? No, so don't copy this. Next, you go to this another 3. Is this greater than equal to the previous number, which is 3? So 3 is of course greater than equal to this previous 3. That means this 3 can be copied and you are at this location. And finally, you have exhausted the array A. So you can say that the original size of the array A was 6. This was the array A 6 size. Now you have an array B, which is of course of the 3 size. So this is basically N. This was basically M. And this B array has been obtained from the array A. Okay. So now that we have understood the simulation, let's see what the question is asking you. They are not saying to make B. Alright. They're not saying to make B. What are they saying is, in the problem, I am not given as an input the array A. This might be a initial understanding when you understand the problem that okay, maybe that makes sense that they will give the array A. No, the trick over here is they are saying I am going to give you this array B. So basically they'll give me 4, 6, 3 as an input. And what are they saying is, can you, or not can you exactly, you have to report some sequence A, that is you have to back create some sequence A, which would have, or if that sequence A would have been chosen as my A sequence, then that would have given me the sequence B. That's the trick. Understand this again. Given the sequence B, which was created by a simulation from a sequence A, guess back the sequence A. So given B, guess some sequence A, which you think is fit for the simulation. That is, if I would have ran this whole simulation of crossing and ticking off the numbers according to the condition that is given to me in that sequence A, then I would have gotten B. This is the whole problem. So if let's say 4, 6, 3 is my given sequence B, then I will report the answer. This is one of my possible answers, that is 432 633. That means if I would have started off with this sequence, I would have gotten 463. Alright, let's now understand this with sample case. Let's go back to the problem. Let's take some sample case. Let's say I have something like this, 17957. So basically the sequence B is 179 and 7. And what are they saying is, a guessed sequence, a possible guessed sequence A is 179357. So I'll write this 179357. Now let's try to counter prove why this A sequence is correct. Let's say that the sequence is correct. So of course the simulation on the sequence A should give you B. Let's see. If I jot down the first value 1, then from the next indexes I start asking the question, is 7 greater than equal to the previous number? Yes. So let's jot this down. Is 9 greater than equal to the previous number? Yes. Is 3 greater than equal to the previous number? No. So let's not jot this down. Is 5 greater than equal to the previous number? Yes. And is 7 greater than equal to the previous number? Yes, it is. So can you see that I have gotten a new sequence B after simulating on the sequence A, and this is actually the sequence B only. So if I would have reported the A sequence as one of my possible answers, that would have been correct because the simulation on this A sequence definitely turns out to be the sequence B. Now I hope the whole problem should be clear. Again, repeating this once more, given a sequence B, guess back any possible sequence A, which you think actually after simulation would have given you the sequence B again. This is the question. Alright, now let us try to understand the question's expected time complexity. Once I have understood the simulation, I need to ask myself, can I run this simulation in such sort of a brute force manner? So for that, we of course need to understand what's the time complexity in this part. So I know that 1 second allows me basically 10 power 8 elementary operations. This is something I know. And then in this problem, it's been given that time limit per test is 2 seconds. So that means if I'm talking about one test that test file that is going to run, it's going to have 2 seconds of a time limit. That means 2 into 10 power 8 elementary operations that is allowed to me for this test. Now inside this test, there are some test cases. Normally how we can picturize that, okay, if I have one test file, it has some test cases with the variable t that is at most in 10 power 4 order. So we can actually calculate the number of operations per test case. But this problem has a unique line that is given over here, that is the sum of values of all n over the test cases, of n over all the test cases does not exceed 2 into 10 raised to 5. Now this is a very important line. What does this mean is basically, if let's say in one test, you're talking about 10 raised to 4 test cases, then every test will have some n value that is in that test case, let's say n1 value, n2 value, so on, so on, so on. So the sum of all these values, sum of all these n values that is given to me, it's not exceeding 2 into 10 raised to 5. So on an average, we should not bother ourselves with number of operations per test case. Rather, we can take a very you can say worst case scenario where we can imagine us to have something like this. We can say simply, okay, inside one test, I had only one test case, and that one test case had that one n variable, which was actually in 2 into 10 raised to 5 order. That means I want to now calculate or get my expected time complexity result in terms of operations I can perform for every test file, not every test case, because of this summation line. All right. That means now this is the value for which I have an upper bound. So if I ask myself that if n is in order of 2 into 10 raised to 5, then do you think an O of n square solution will work? Of course not, because n square means I'm getting 2 into 10 raised to 5 square, which is approximately 4 into 10 raised to 10. Now this number is greater than 2 into 10 raised to 8 number of operations, which was allowed for every test. That means n square will not work. So just below this, maybe n log base 2n. This is something like a very common time complexity we try to get for 2 into 10 raised to 5 or 10 raised to 5 order. Then specifically, yeah, this might work because 2 into 10 raised to 5 into log base 2 of 2 into 10 raised to 5 will keep me somewhere below the 10 raised to 8 limit. And if that works, then anything below this O of n, then maybe so on, you create something even below this log base 2n, so on, and up to a time limit of constant, all of this is going to work. That means I have an upper bound at complexities which look somewhat in order of n square, and below that stuff is going to start working. Below that, I'm good to go. So assuming my logic is right, if I get a time complexity that looks in these green sort of orders, I know I'm going to have a correct solution. I'm not going to get a TLE. And this is my expected time complexity discussion, which is very important because this is helping me remove all the redundant ideas I could have had in my head. I will not bother myself to create a logic that runs in n square, because no longer, like, I have understood this fully that n square solutions are not bound to work. So my logic, even though might be right, even though might be brutally correct, is not going to get me an accepted solution. All right. So let's move on to finally solving our problem. So solving this problem has a very, you can say a very basic idea, right? A very clever idea, to be very specific. Let's try to focus our energy on B first and then ask ourselves very important questions. I'll tell you what. So I have the, you can say, the sequence B. This is B1, this is B2, this is B3, this is B4, this is B5, so on, so on. This is Bn because you have an n-sized solution. Okay. Now the question that comes over here is very simple. The question that comes over here is, if I'm standing at a number bi, then the argument is this number, of course, if has been noted in the sequence B, it must have been brought down from the sequence A. And to be brought down from the sequence A, this number should of course be greater than equal to its previous number. Does this make sense? I'll write this down. You can say every bi if has been jotted from A must be greater than equal to, you can say, or like this, greater or equal to the previous number in A. This is arguably true, right? If bi has been brought down or some number has been brought down from the original sequence A to this new sequence B, then that number must be greater than or equal to the previous number in the original sequence A. Let's understand this thing with a live example. Let's say I have the numbers 4, 4, 6 and 3. Now let's say that this is B. So I'm talking about something of creating A. Since I'll talk about the first number, so first number of course is there because first number is directly jotted down, so 4 is there. Now if I talk about this 4, this has been jotted down from B. In the original sequence A, this 4 should be greater than or equal to the previous number. If let's say I keep 4 over here as it is this current 4 greater than or equal to the previous number? Yes it is, so I'm good to go. Great. Let's talk about 6. Is 6, if it's jotted down, that means it must be present in the sequence A and it should be greater than or equal to its previous number in the sequence A itself. So I can maybe keep 6 over here directly because 6 is greater than or equal to the previous number 4. So it's good to go. But when I come to 3, it's a problem. 3 has to be jotted down. 3 is present in the sequence B. That means it is coming from sequence A. But if I keep 3 as it is, 3 is not greater than or equal to the previous number 6. So there must be some number that is coming before 3 which is helping me to jot 3 back. This is a very important point. I'll repeat this again. You focused your energy on this number 3 and you said, okay, this 3 number present in the sequence B must be there because it is jotted down from the sequence A. If it has been jotted down, I'll go back to the argument. If it has been jotted down from A, then it must be greater than or equal to the previous number in A. Now, previously to this number, there is 6 kept. So that means there are some empty positions to be filled between this 6 and 3. Else, this 3 being not greater than or equal to 6 will never be jotted down. There must be some number x present over here, which is actually less than or equal to 3 for 3 to be made jotted down back to the sequence B. If this x is not present, then this 3 can never go to the sequence B. This number x is definitely present. It's coming between 6 and 3 and it's helping 3 jump itself or be jotted down to the sequence B. Now, what would this x number be? Can we generalize this? Of course we can. Very simply understand this. All this x number needs to be is a number that's less than or equal to 3. Less than equal to 3. Let's focus the words. Less than equal to 3 or 3 greater than equal to x. Can I keep x simply as this 3? Or if let's say this number is arguably, let's say this number is let's say y, then I can keep y just before that because y is of course less than equal to y. It's, to be specific, it's actually equal to y. So very cleverly, because we use the less than equal to, so we did not focus on our less than part or greater than part, we just focused on our equal part. We said, okay, if 3 has to be the number that gets jotted down to the sequence B, then let's keep the previous number 3 itself or a copy of that number only. It will help me. Let's understand now. If let's say your sequence was 4, 6, 3. What did we take? 4, 4. Yeah, 4, 4, 6, 3. So I can do a very simple if and else check over here. I'll say that first I'll jot down the number 4 as it is. This is the first number copied. Now I'll have 2 conditions to ask myself. 2 conditions to ask myself. I'll write this down. I'll say, okay, standing at a BI number, is this BI number, you can say, greater than equal to B of I minus 1? Do I feel that the BI number is greater than equal to the B of I minus 1 number? If it is, then of course I know that there is no such number that should come between it because automatically this previous number is helping me jot down BI. Because BI number is greater than equal to the B of I minus 1 number, automatically it's going to help me jot down BI from the sequence A. So I'll say, okay, then do nothing and simply jot down this B. So if I go to this 4 over here, 4 is greater than equal to the previous number. So I'll jot down this 4. I'll write this over here like this. 4 is kept. Then I'll jot down this 4. Not a problem. Now let's go to 6. What about 6? 6 is greater than equal to 4. That's the previous number. So I'll jot down 6. Not an issue. But the other case is now this. If let's say BI number is less than B of I minus 1 number. So if I'm talking about the number 3, then number 3 is less than the previous number. That's actually 6. That means if 3 is jotted down, if 3 is actually coming, it should be happening if some number between 6 and 3 is helping 3 to go back to the sequence B. So I'll say, okay, let me create a copy of 3 and then one more 3, and this is working fine. Because now if you run a quick simulation in your head on this array A, you will get 4, you will get this 4 also, you will get this 6 also. Now you will not get this 3, so this 3 is not present, this 6, this 4 all passed. This 3 is not present because this 3 is greater than, less than equal to 6, but the next 3 is going to be present because the previous 3 helped it, or the previous copy which we created helped this number to be jotted down to the pattern of B, and that's why this number went to the sequence B and it got placed. So this is the whole idea. This is what I can follow in order to create my sequence A again. Okay, so I hope this is clear. This can be a confusing problem, right? Like to understand what is the original sequence A, how is that number helping me to get back jotted down to B. It can be a bit confusing, but if you pause the video and you try to understand this ideology of greater than, less than, and so, you will get the problem very quickly. All right. Just the basic idea in this problem is to make sure that if some number is present in B, then there must be some number helping it to come to B from the original sequence A. Now, either you have to create that number or you don't create that number. When you actually don't create that number, that means you are actually talking about a condition when BI is greater than or equal to the previous number. So in this case, you don't need to insert any number in between. But if this number is less than the previous number, then you must think this very cleverly, that there is some number X that is coming there, which is helping that number to go back to the, or being jotted down to the sequence B. And that number is less than or equal to that number X which we're talking about. X is less than or equal to this number. So this X number can generally be taken as that number itself, which will automatically help me give that number the power to be selected and jotted down in the sequence B. All right, so very maybe a confusing but definitely a clever problem once you get this part. Let's move on to a coding part and understand this. How do we implement this out? So I have the vector B over here. Like first of all, I have the test case T, I take the input, then I have the array, the number N input, that's the size of the array B, and then I have this array or vector, whatever you call this. I have taken a vector in this case of B of N size. Then I have also a vector A. Now remember, I haven't discussed any size of A because I know that the size of A is variable. It is going to be that actual size M, which can change because my sequence, how am I creating the sequence is different, right? Maybe at some place I do want to insert some number, maybe at some place I don't want to insert a number. So I cannot predefine any size of A. The size of A is not defined initially, it is variable. So I'll keep this empty. And then what I'll do is I'll take the input of the array B. So up till here, all I'm doing is taking inputs. And then the array A, of course, starts with the B0th number being copied. Because initially, you know that if your sequence A was given, you were automatically copying the first number. That was A1 actually in the given problem, but we are talking about zero-based indexing when we solve the problem. So we want to copy B0 reverse in the reverse way. You can say that, okay, B0 must be copied from A. That means in A, B0 is always present in the first place. So I'll push back B0 first. And then I'll start my loop from 1, go less than n. Why 1? Because I've of course utilized the 0th position number. So I'll go back to the first position. Now I'll take these two cases. I'll say, okay, is my current number Bi greater than or equal to the previous number? If it is, that means this number has to be jotted. And this can be jotted directly because in the original sequence A, the number before it in the sequence A is less than or equal to that number. So this number is good to go. I don't need any extra copy of that number. This number automatically has the power and it will definitely be jotted down to B. So A will only require a single copy of Bi. But if this is less than Bi minus 1, then I will require double copy because I would need that extra X number between those two positions to help that number get the power to be jotted down to B or be selected to be go down to the array or sequence B. Right, so this is the whole ideology. And then when I see out, what do I want to do in the final problem? They have said that you want to first print the size, that is the integer M, and then you want to print the direct array. So that's why I'll print the size of A by simply saying A.size. This is going to give me whatever that size is after I've ended the loop for this A creation, and then I'll simply print every number in A by a simple, I have used a for auto loop. You can do of course this by any other method you want. Effectively, you just want to print the size of A and the array A itself. Alright, so this is the whole code of the problem. Now what is the time complexity? I'm using n order over here to take the input, then I'm using another n order over here to take the creation of A, and inside this I have only constant checks, so no big deal. Pushback also runs in constant time complexity, so I don't need to be worried about that part. All of this is pretty much constant. That means effectively I am getting a time complexity. If I jot this down, the superseding term turns out to be O of n. This is O of n, and O of n of course works because O of n is of course in 2 into 10 power 5 order. So this is like O of 2 into 10 power 5 order, and we discussed back in that problem also that if I get a O of n based order, I'll be good to go. Overall in one test file this is going to work. So that's why this is a good time complexity that we have achieved. It's going to get me a accepted solution, of course being my logic right, and space complexity is only dependent on the size of the array, which is effectively O of 2 into 10 raised to 5 again. So this is also going to work. I'm well within my boundaries, my logic is correct. This is definitely fetching me an accepted solution. Alright, so fun problem. Idea of this sequencing part is very important. Now you can take this as a homework so as to think what other values of x you can take. You can also have some other values of x. There's no need or no fixation that if I've said that the x value can be the copy of that same number, you have to fix yourself to that part. X can also be some other number also, right? You can think that part, keep that as a homework, and try this problem once more with your idea. Originally, you should understand this, since we are not restricted towards creating the sequence A to be something exactly. I want to create the sequence A in such a manner where I make sure that the number which I want to be selected to B definitely comes up. So if it has the power to go to the sequence B when I follow the condition, that's fine. But if it doesn't, I will have to externally do something, that is in this case insert some extra number, that copy only, to make that number go back to the array B. Okay, so I hope you like the video. Thank you for watching.